All right, so hi everyone, how are you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT. And in this particular channel, every concept of physics, chemistry, and maths are being taught to you completely in English. And the level of our discussion is something else. Okay, so we are discussing not only JEE Mains level problems, we are also covering JEE series is meant. So some students were requesting me to solve some Olympiad level questions, also help them prepare for NACP. Okay, and uh, help them identify how to approach really tough problems. So this is why I have started this series. So in this series, we discuss like really tough problems on different topics, and this is a discussion where we will be talking about problems from rotational motion. Okay, so this is part three of that discussion. We've already had two classes where we have discussed problems on rotational motion. So hi AP, how are you? All right. So before we get started, before we move ahead with today's discussion, let me just introduce myself for those of you who might not know me yet. So my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi, and I have been teaching physics for almost past 8 years now, both for advanced, mains, and Olympiads and other competitive exams also. So all this teaching has been offline so far. So far for 8 years, I had been teaching offline, and there I had been associated with some of the topmost institutes that you know of. Okay, as a student, I myself was All India rank 447 in the JEE and also All India rank 192. So these are my results from the two stages of the JEE exams that I took. Okay, so right now, like you gave your mains in advance. So we also used to have two stages of JEE. In the first stage, I was All India rank 192. In the second stage, I was All India rank 447. Now, I also qualified the NTSC stage 2 as a student, and I was also in the top 1% in the NSCP examination as well. Okay. Now, I've already coached many students to top ranks in JEE Advanced, JEE Mains, and other competitive exams. Help them secure, qualify NSEP, INPHO also. Okay, so now I hope to continue doing that with you guys here. So a great way of you guys being able to, carry on with your studies in a great way, even in this lockdown and even with these conditions, is by getting yourselves the Unacademy subscription. So the subscription will help you with benefits like live classes where you get to interact with your educators. These classrooms also have live polls and leaderboards, which keep them highly interactive and fun and quite efficient, actually. So these classrooms also have, along with these, courses, you are also part of a lot of test series and you have regular analysis sessions which keep you on your toes and keep you aware of the competition. Okay, and of course you have live doubt clearing sessions. So that is a wonderful feature. In all the Unacademy Plus courses, every fourth session is a dedicated live doubt clearing session where you interact with your educator about doubts only for the entire session. Okay, so after three teaching sessions, every three teaching sessions, whatever doubts you may have doubts regarding theory, a concept, or problem solving strategies, you can discuss them all, okay, in an entirely dedicated session. Now, along with all these benefits, Unacademy is also providing you a wonderful opportunity, which is to be able to study from all the topmost educators all across India from the comfort and safety of your home. All right, so I think that's a huge advantage. That is something that I could not have even dreamt of in my time back in my day. But you guys are getting this opportunity, so make sure you're utilizing this and making the best out of this. So the first step towards making getting all these benefits is to install the Unacademy app. The moment you do that, you unlock a lot of free features for yourself. So these include free courses. So there are a lot of free courses on the Unacademy app which you will be able to attend just after installing the app. Then you have special classes. So you can attend these special classes. These are also absolutely free of cost. Okay, you can attend any of these special classes just after downloading the Unacademy app. Plus, you have quizzes like the one that we keep having every Tuesday. So you can take part in these completely free just after installing the app. You can unlock all these features by using my code RD Live. Okay, so download the app, unlock all these wonderful features using this code. Okay, so again, a lot of benefits without even having to buy the subscription. Now, once you have attended all these classes, once you have gotten a flavor of how your plus subscription is going to be, once you have had that experience, if you finally decide to get your plus subscription, then this is how you go ahead with that. You go to the plus section of the app, you select your goal as IITJ, and you click on the get subscription button. All right. Once you do that, you'll be redirected to the payment page where you will have a box which will say, do you have a code? So don't forget to mention this code there, RD Live. That is my code. If you use this code, you will get a 10% off on all your subscription fees. And also now you can choose from two kinds of subscriptions plus are iconic. And when you click on proceed to pay, you will realize you have a lot of payments. Now, if you take a look at the subscription fees are already kept very, very competitive. So for a 12-month subscription, you realize the cost is coming out to be roughly 2,800 a month, which is very, very less. Okay. And for a 24-month subscription, the cost is around 2,100 rupees a month. So again, at these prices, the kind of quality education that you'll be getting will be completely worth it. So make sure you're getting your Unacademy subscriptions as soon as possible. Okay. Now let me tell you quickly about the iconic subscription. Also, this is something that will take your IIT JEE preparation to the next level. And how does that happen? So you'll be allotted personal coaches. Okay, these personal coaches will closely monitor and mentor you throughout your JEE preparation. You will be getting a lot of personal guidance. Then you will also attend a lot of IIT JEE workshops. You will be receiving expert guidelines from time to time. You will be getting a study planner, which is very, very important. I know a lot of you students could use that. And of course, you have regular text analysis sessions. So these are wonderful, wonderful features which will allow you to take your JEE preparation to the next level with the help of a closer mentor, a more personal guidance. Okay. Now, another very great event that the Unacademy keeps organizing is the Unacademy Combat. So, if you don't know about this, this is the most competitive gamified IIT JEE battle. Okay, now you can compete live in this, test your understanding, test your level of preparation, see where you stand amongst your peers, and if you do well, you also stand a chance to win yourself a lot of rewards and prizes, which include even year-long subscriptions, which are being given away for free for top performers. Okay, so the next event of Unacademy Combat is going to happen live on the 3rd of January. You can register now for that using the code RDLive. So use this code and you will have my best wishes and I'm sure you will crack it. Okay, and win yourself some really, really cool prizes. All right. Those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link. This will make sure that you're receiving all the notifications of all the lessons and sessions that are happening here on this particular channel of YouTube, so that you're not missing out on any of the amazing content that is being given to you completely free of cost. Okay. Next, so why don't we get started with today's discussion? So today, again, as I said, we'll be discussing some really tough Olympiad and advanced level problems from rotational motion. Okay. So let's get started. So this was a problem that I had given to you last time. Okay, if you remember. In the last time, I had asked you to try this problem, and I told you that there will be an issue with this problem. This is something which is not usually solved using your regular methods. Okay, and this kind of a problem will help you attain a good insight on something which you usually don't see. Okay, so why don't you guys try this? And let's see if you can figure this out. As I said, I am bringing you these problems, these very interesting problems, these different cases, okay, which you do not usually encounter. So when you analyze such a situation, not only do you understand how to approach such complex problems, but trust me, there are new concepts that you will figure out, which probably you never paid attention to. So as I keep telling you guys, so a lot of people study, a lot of people get to know a lot of things. They don't really think about the concepts in depth. And to be able to solve all such kind of questions, all advanced level questions, you don't only need to know your concepts, you need to understand them thoroughly and understand the root of those concepts, understand them at a depth. Okay. So here is the chance for you to do that. Let's try this problem. Let's see if you can figure this out. Okay. All right, people. So again, I think a lot of people probably did not know about this session because I've moved up the timing by half an hour. So I usually host the session at 8:30 every Saturday. So today I just got free earlier, so I moved up the timing by half an hour. So I think that is the reason why a lot of people are not even here. Hmm. Let's see. Okay, AP is still here. AP likes to follow us closely. So good to see AP here. All right, how about others? So try this. This is a very interesting situation. Okay. And let's see if you can figure out what's different about this from all the other situations you would have encountered so far. Okay. All right, AP. No worries, no worries. I'm sure people will join in a bit. All right. All right. Those of you who are already here, why don't you try this? How do you think you will approach this problem? So try and tackle this, and then we will discuss about how you should have gone about tackling this. So it doesn't matter even if you get it wrong, okay? This is supposed to be a tough, tough problem, okay? Not your usual problems that you see. This is a tricky, tricky problem. So let's talk about the problem. Let's go over the question statement first. So the question says a small clamp of mass small m is attached at point B to a hoop of mass capital M. Okay. Now the system is released so that from rest when the angle theta is 0. So here is the situation that has been shown to you. Okay. So this is a hoop that has a mass of capital M, right? Along with this, you have at point B, you have attached a mass small m, and this is the angle theta. So angle theta is the angle with the vertical of the line joining the center of the hoop and this guy. So when theta was 0, then this system was released from rest. Okay. And you've been told when it is released, it just starts to roll without slipping, knowing that capital M is equal to 3m. Determine the angular acceleration of the hoop when theta is 90 degrees. Okay, so try and do this. ASAP, this is a tough one. I agree. I agree. But still, you have to try, right? This is something that can be easily asked in JEE, okay? This is not something which is out of the syllabus. This is a very, very nice problem for your JEE Advance. Okay. So, yeah, slightly unlikely to be asked in mains, but a very, very good problem for advance. Okay. Advanced people like asking such questions, all right, which have slightly tricky situations and where you do not apply the usual thing. Here something is different from the usual situation. So advanced people like asking such questions, all right. So you should try it. Hello Tanya, how are you? All right, so more and more people are joining finally. Okay, okay. Hmm. So let's see. So AP says C. Okay. Hmm. All right. Unfortunately enough, I don't think that is the answer. Hi, Nothing Peace. How are you? So, did any one of you try this question? I think in the last class, I told you guys to try this question and leave your answers in the comments. Let me just quickly check the comment section of the last class whether any one of you tried and left the answer in the comments or not. I really doubt it that you did, but most of you I know, are so lazy that you don't even want to try the question after the class. So why don't you try this right now? Until then, let me check out the last class that I took on this. Okay. Yeah, so here I have it. Okay. So yes, zero comments. Absolutely. This is what I thought. Okay. All right. Worries. Hmm. So then let's. Sir, I got option C. So nothing. Please says option C. He's getting. No, unfortunately, option C is wrong. People. Oh, this is wrong. Okay. Ah, sorry to disappoint you. I told you this is a tricky, tricky problem. Okay. I'll tell you what the problem is. The problem is that what you don't realize is whenever you're dealing with these kind of problems of rolling, right? So what we do usually what we do is we take the torque about the bottommost point, which is the ICR, right? Instantaneous center of rotation, and we use the equation. Yes, so D is the correct answer. Yes, nothing, please. Is absolutely correct. All right. So the main problem is that what we usually do is we apply the equation tau about O equals I about O into alpha, right? You use this equation most commonly in cases of pure rolling, right? Now, the problem here is that what you don't realize more often than not is that O is a non-inertial point. O point has an acceleration, even though it is the center of instantaneous center of rotation. So it has no velocity, but it has an acceleration. So that is where the problem arises. Okay. So I have told this many, many times, but I think I still need to repeat. Note O is the ICR which has zero velocity but has a non-zero acceleration. Again, trust me, even a lot of times, a lot of teachers do not realize this, if I may say so. So it is it is a non-inertial point. Okay. So whenever you're taking talks about a non-inertial point, okay. Whenever you're taking the talks about a non-inertial point, then you must add pseudo torque also. So here the correct form actually is tau about O plus tau about pseudo forces about O should be equal to I about O alpha. Now, usually what happens is if the body is symmetric like this, so the center of mass is usually here, and you realize the acceleration of this guy is like this, omega square r. That is the acceleration of point O. Okay, it has a centripetal acceleration with respect to the CM, and CM has zero y acceleration, so that will be the acceleration of the ICR with respect to ground. So corresponding to this, you have to apply a pseudo force. Now pseudo forces act on CM. So usually what happens is that this pseudo force acts right here, which passes through O, and that is why it produces no torque. So this is zero usually, or if CM coincides with geometrical center, right? So as long as this happens, sir, I have a doubt. Can I ask you? Of course, please go ahead. No worries. But in this particular question, what is happening is you have an additional mass which is attached here, right? You have an additional mass attached here. So where is the CM? The CM is on this line somewhere. Okay, so CM is at some distance x away. So this pseudo force would apply here instead of the center C. This is the center C. This is the CM. Okay. So this can now produce a pseudo torque about O. So I have to take that pseudo torque into account. So now if I had to solve it, I would have said if I take torques about O, now let's draw an FBD. Okay, so let's draw the FBD. So I know what are the forces acting on my system. So I will have let's say some N from the ground. Okay, then I will have some friction from the ground. Let's assume it is like this. It may be in front also. So let's take the front direction only. Let's assume it is in front. Then I will have BMG acting here. And then I will have MG acting from here because I have to calculate this at theta equals 90. Okay, that is interesting. And now I have to apply the pseudo force also. So F pseudo. So this would be the correct FBD when I include the pseudo force. Now when I'm taking torques about O, you realize I will have no torque due to N because this is passing through O, no torque due to friction because this is passing through O, no torque due to 3mg because this is also passing through O. However, I will have two torques now, not only for mg, also for this pseudo force. So now when I write torques, okay, so let me just solve this one and then I will answer your query. Okay, nothing please. So taking torques about O. Now what you will figure is that there is a torque due to mg, which is mg into r, plus there is a torque due to the pseudo force. Now pseudo force is m times the acceleration of the non-inertial point. So m is 4m of the cm into acceleration was omega square times r. Okay, and the distance at which it would have acted, x, would have been, because this was 3m, this was m, so x would have been 3r by 4. Correct. So I would have applied m times a times 3r by 4, and this should have been equal to I about O times alpha. So from here now I can find alpha, and when you do that, you will get this answer. Okay, now I hope you guys followed this. So please remember, if your center of mass does not coincide with the geometrical center, then while taking the torques about the ICR, always include the torque due to the pseudo force. Okay, always include this term also. So again, as I keep saying, this kind of question will only be asked in advance. I don't think means people would bother for such a variation. Okay, all right. Okay, so what has nothing be saying? So it says, so what will happen if Earth has more than one moon? So, okay, what do you think should happen? What do you think should happen? In what sense? In what sense are you asking me? So you do realize we keep launching satellites, right? So Earth has a lot of satellites. Earth already has a lot of satellites also revolving. So Moon is just a natural satellite, right? We are already launching so many artificial satellites also. So technically speaking, Earth currently has lots of moons. Okay, no. If Earth had two moons, then you would have either seen two two moons at night, or you would have seen a moon during the day also. Okay, depending on where the moons are. Okay, you would have just seen an extra moon in the sky. I don't think nothing else would have happened unless probably something would have changed with the tides. With sea tides, something would have changed, because sea tides, are acting at because of the presence of gravity of the moon, and you could have had more solar eclipses, because if there are two moons, then they will eclipse the sun more number of times, right? So yeah, those are the possible effects. If you ask about me, otherwise you'll have to be a little more specific about exactly what kind of effect are you asking me for. Okay. All right. Now let's try another very very interesting problem. So this says a uniform sphere of radius small r rolls down an incline without slipping. Now it hits the horizontal surface, and after slipping for a while, it starts rolling again. Assuming that the sphere does not bounce as it hits the horizontal surface, you have to determine the angular velocity after it has resumed rolling. Okay. So let's see if you can figure this out. So this is another seemingly very tricky problem, but again a wonderful, wonderful problem that can be asked in advance. So great problem for advanced level problem hai ye. Okay, and the solution is very very easy. Turns out it does appear a little tough, but the solution is very easy. Hello Rohit Mittal, how are you? Okay, so what's with all the images? Hmm. Change in gravity? Change in gravity of what? Change in gravity of what? You mean acceleration due to gravity? You mean acceleration due to gravity would change? No, no, that wouldn't happen. That would not happen. Okay. What else? What else are you looking for? When you'll have to be a little more specific than that. Okay, nothing piece. It's easy. Noman says it's easy. So are you talking about the question? So yes, find the answer quickly, Noman. This is easy. This is supposed to be advanced level. This is not the Olympiad level actually. This is advanced level only. So yes, if you have prepared well, this is easy in fact. No, 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 nothing will happen to acceleration due to gravity. Why would that change? Why would the acceleration due to gravity change? Acceleration due to gravity is the force that Earth is applying on you, right? Does it depend on the presence or absence of other things? Does it depend on the presence and absence of other things? So you know, in Newton's law of gravitation follows superposition principle. The force between two masses is independent of the presence or absence of third mass or a fourth mass. Okay. The acceleration due to gravity would have never changed due to that. All right. Okay, how about this one, guys? तो भाई इसका भी आंसर कुछ बता दो. So here, as I said, you've been told that the sphere is rolling down the incline, hits the horizontal surface, starts to slip up for a while, and then starts to pure roll again. So when it starts to pure roll again, what will be its omega? If omega 1 is its initial omega. Okay, find the answer. Let's see. Okay, I don't know how many of you saw my session where I told you how to work with options, how you can work with options in your MCQs. है ना? If you notice in this question, what happens if beta is 0? A is 5. Okay, A is correct. Okay. So again, if you watched my session on how to use options, then you know if beta is 0, I hope you will realize if beta was 0, then the omega would not have changed, right? Omega would have been equal to omega 1. So if beta was 0, so try substituting that. Try substituting beta as 0 in the options. Agreed. So only this option and this option have omega final as 0, as omega 1 when beta is 0. So two options are already eliminated. The correct answer has to be either A or C. The correct answer has to be either A or C. So you already have a 50% chance of getting this right. Right? Just by using common sense, even if you don't know how to solve this, you could have narrowed it down to two options and now you have a 50% chance of getting this right. So a lot of people are saying A. All right, let's see if that is correct. So how would you solve this? The very interesting thing is, so if I draw the FBD here, okay, I wanted to draw it again, but I'm a little bad at drawing. So if I draw the FBD, notice that here you would have had and then here you would have had N, then you would have had friction. Okay, something like this, and of course mg sine theta. Right? Let's draw that also. This what the FBD would have looked like. Okay, now afterwards, after it strikes this, and afterwards when it is moving like this, again, while it is slipping, it would have had mg, it would have had n, and it would have had some friction. Or friction, I don't know, could have been forward also. So these would have been the forces acting on this. Are you a mechanical engineer? Yes. You did not know that? I studied mechanical engineering from IIT Delhi. Nothing peace. ये रोज इंट्रो देता हूँ, लोग सुनते ही नहीं है यार. हद हो गई. Here, कहाँ गया? ये देखो भाई, ये रोज इंट्रो में बताया जाता है. What is the specialization? So स्पेशलाइजेशन जो होता है वो एमएस में आता है, हायर स्टडीज में आता है. बीटेक में कोई स्पेशलाइजेशन नहीं होता, जनरल कोर्सेज होते हैं. ओके, वो जो है वो एमएस वगैरह में आप स्पेशलाइजेशन करते हो. So I've done courses on all sorts of things. I've done courses on automobiles. And I did a course called internal combustion engines. I did a course called fuels, pollution, combustion. Did courses on mechanical vibrations. Did courses on thermodynamics. A lot of courses on thermodynamics. Uh, Heat exchangers. There was this course that I did. I don't even remember now. There were so many courses. So there was hardly any specialization. You just do a general, like a small course for everything. Okay. Generally, your specializations come in higher studies. When you go for your MS, then you specialize. Okay. That is where that happens. Now, what happens is here, if you talk about the external forces, so just before it hits this, just before it hits this, and just after it hits this, what you realize is if you choose this point, then the friction acting here and the friction acting here, both these frictions pass through this point O. Okay, I hope you realize. So about this point, about or any point here, about any point here, you would have seen that the total angular momentum would have remained conserved, because about any point lying on this line, after it has touched this, there would be no external impulse on this. Okay, so this can be solved using your angular momentum conservation. Okay, I can say we can use angular momentum conservation about a horizontal point, or horizontal about the horizontal landing point. So wherever it lands, immediately it will receive some impulse. So when it lands on the flat surface, what happens is it will immediately receive some impulse actually. Now when it lands here on the horizontal portion, just lands here. हाँ, यहाँ से उठकर जस्ट यहाँ पे लैंड किया. इस पॉइंट के अबाउट इम्पल्सेस मिल रहे हैं, एक इम्पल्सिव फ्रिक्शन मिलेगा एंड एक इम्पल्सिव नॉर्मल रिएक्शन मिलेगा. बट बोथ दीज पॉइंट्स, द इम्पल्सिव N and the impulsive F, will both pass through this point. Okay, so there will be no change in the angular momentum of this ball about this point of landing. So if this point is P, all I need to do is apply conservation of angular momentum about this point. That is it. So let's talk about the initial angular momentum. Right. So initially, just before the impulse, the velocity is like this. Okay. So if is like this, I can break it into two components, right? This component would have been b cos beta, correct? If your this angle was beta, you will realize this angle is beta and this angle would be beta. So what will be the angular momentum about P? So here is my point P. Let's highlight this. This is the point of landing, about the landing point P. So initial angular momentum, L initial about P, would have been again, all the signs would be along the k axis only, so I'm not writing the vector signs. So would be just before the collision, it would have been p cos beta into mvr. Okay, so this would have been in the positive x direction, positive k direction, and so I'm writing a plus for this. So I'm taking plus k as positive and negative k axis as negative. Okay, plus I will have some ICM omega term also, and ICM omega term would be 2 by 5 mr square times omega 1. right? This would have been the initial angular momentum. And finally, when the pure rolling starts, so the answer would be V M R or MVR. Okay, finally, imagine this guy is moving with V and rotating with some omega and pure rolling. So due to the translation of the CM, I will have angular momentum MVR plus I will have 2 by 5 MR square and omega also, right? And because initially and finally both pure rolling was happening, so here I can write V1 as, so this is V1. Okay, V1 would be omega 1 over R. Omega 1 times R, and V will be equal to omega times R. All I need to do is substitute those values. So let's see what I get. I will get omega 1 m r square cos theta plus 2 by 5 m r square omega 1, and this should be equal to m r square omega times 7 by 5. Okay, so you can cancel out the mr squares, and what you will get is omega equals 5 omega 1 by 7. 5 तो cancel हो जाएगा ना. So this times you would have had 2 plus 5 cos theta. This would have been your answer. Okay, I don't know how many of you followed this. All the idea is that when this transition happens, the only impulsive forces will be acting from the landing point, okay, where it lands. It will receive an impulsive N, it will receive an impulsive friction for the time being. So if I take the angular momentum conservation about that point, then about that point, there is no external torque ever. If I simply apply angular momentum conservation, then this is the answer that I'm getting, which is essentially answer number A. Well done, you guys. All right. Very surprising that so many of you got this correct. Very nicely done, guys. All right. Now let's talk about another problem. So this is a wonderful, wonderful problem. ये कैसे करेंगे भाई? ये थोड़ा टफ है. ये थोड़ा ज़्यादा टफ है. ये क्या कह रहा है? The question says that a 30-gram bullet is fired with a horizontal velocity of 350 meter per second into an 8 kg wooden beam A. Now the beam is suspended from a collar of negligible mass that can slide over a horizontal rod. Neglecting the friction between the collar and the rod and determine the maximum angle of rotation of the beam during its subsequent motion. क्या होगा? This is just hanging like this. Something strikes this and this will slide. This will start to slide and this will also rise. So what is the maximum angle to which it will rise while sliding forward? Okay, so that is what you have to figure out. So what do you think you can do? What do you think you can do? Now you can imagine that the bullet got stuck into that wooden beam. Okay, you can imagine that the bullet got stuck into the beam. इसके बारे में सोचो. This is very tricky. This is supposed to be a very tricky problem. Again, this can come in advance also, and this can come in Olympiad also. So I would say this is a good problem for both advanced / Olympiad. It's a wonderful problem. Again, this is presenting you a situation which you usually do not encounter. Usually what happens is that this point is kept fixed, right? This point is kept fixed. वो वाले problems आपने किए होंगे. But what happens if this point is movable? अब क्या होगा? So how would you analyze this? So try this, think about this, and let's see if you can figure this out. Okay. So today I am discussing only 2-3 problems. Okay. I wanted to discuss only a few problems today because we have already discussed a lot of problems on rotation. But still, there were some really nice problems that I wanted to discuss with you guys. Okay. So how do you think you would have approached this? Think about this. Think about this. So I'll tell you, the approach is actually very easy. This seems like a very, very tough kind of situation, but when you figure this out, the approach is rather easy. Now, what will happen? Will happen. Okay, think about this. So when this bullet strikes this will start to slide and this will also start to rotate, right? So at the maximum angle of rotation, the entire thing would be sliding. Can I say that? How will the motion look like? How is going to be the motion looking like? Motion will look like something like this. You have this collar A and your entire rod would have become like this. Okay. And everything must be moving like this. With everything must be translating at the maximum angle. At the maximum angle. See, with respect to this point, the at the maximum angle it would have come to rest. So every point must be translating, right? So if the maximum angle is theta, if the maximum angle is theta, then what will you have? What will you have? Let's see. Let's see. So can I say this V final V would be equal to VCM? Final V at max theta would be equal to VCM. Correct. So if I can figure out the VCM initially, then I can figure out the answer. Now, initially using momentum conservation. Now here I can apply momentum conservation. Why? This end A is not hinged, so there is no external impulse that will be received by this system in the x direction, right? So I can apply momentum conservation directly. So I have a 30-gram bullet. So 30 over 1000 to 350. This is the initial momentum. And let's assume again I can ignore the weight of the bullet in front of the mass of the wood. Okay, I have 8 kg, and in front of 8 kg I can almost ignore the 30 grams. So I can say 8 into V M. Okay. So from here I can figure out what my VCM would be. Okay, so VCM would be equal to this would be 105 over 80. Okay, now what you can do is, so this is the final velocity that you have here. Now, just after the collision, what happens is just after the collision, let's imagine just after the collision, I cannot apply energy conservation right away. Please note. Why not? Why not? This is an inelastic collision. In an inelastic collision, energy conservation cannot be applied. Okay. Please note. What I can do, however, is that I will realize when this guy strikes this guy gets some omega also and some VCM. Okay, and finally the translatory K is in place. It's the rotational K that is going to get converted into the potential energy. So the height that it will gain would be due to the rotational energy gained. Okay, I hope you can figure that out. So even just after the collision, it will start moving with VCM that will never change during the course of motion, and it will have some omega. So from here to here, what you will realize is from here to here, the rotational kinetic energy will go into the potential energy that it gains while it rotates, and the translatory kinetic energy would have remained just like that. Okay, so if I can find the rotatory kinetic energy, How do I do that? How do I do that? I can apply angular momentum conservation about any point on this rod. Okay. Or for that matter, anywhere I could have applied. It doesn't really matter. So let's consider a point P and apply angular momentum conservation about P. So applying L conservation about P. Let's see what I get. So initial angular momentum would be 30 into 350 by 1000 into 1.2. So that is the angular momentum of the bullet. And finally, I would have had M, which is 8. Finally, I would have had 8 times VCM into zero point 0.6, and I would have had plus ICM omega. ICM omega would have been 1 by 12 into 8 into L square, which is 1.2 whole square into omega. Okay, I can now that I know VCM from momentum conservation, I can find omega. And when I find omega, I can find the maximum height h of VCM. So I can finally say and half ICM omega square, which is the rotational kinetic energy, to be equal to mg L by 2 1 minus cos theta. This will be the gain in potential energy. So the rotational kinetic energy would be going into the potential energy. Okay. Now you can solve these equations and get your answer. And this is how you would have approached it. Applied momentum conservation, applied angular momentum conservation, found the omega, and then realized that while this is sliding and rotating, it's the rotational kinetic energy that will go into the potential energy. To apply energy conservation, put that rotational kinetic energy equal to the gain in potential energy, and you would have found your answer. Okay. The important thing is I wanted to discuss the approach of this problem. I hope that approach is clear. Okay, if you have any doubt regarding the approach of this problem, you can let me know. ये approach clear है सबको? बता दो भाई जल्दी 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 बता दो. Just go through the approach and you can solve the equations and find the answer. Okay, that's not a big deal. Okay, so should we try another problem then? Should we try another problem? Let me know fast. All right. So here is a simple looking problem maybe. Okay. So let's try this. You have been told 240 mm's radius cylinder of mass 8 kg rests on a 3 kg carriage. Okay, the system is at rest when a force P of magnitude 10 newtons is applied as shown for 1.2 seconds. Knowing that the cylinder rolls without sliding on the carriage and neglecting the mass of the wheels of the carriage, determine the resulting velocity of the carriage and the center of the cylinder. And here are your options. So try this. Again, a very, very interesting problem this you will have. Okay. And I have a very unique way of solving this problem, by the way. I have a very, very unique way of solving it. Okay. We'll talk about that. See. Why don't you guys try this? Obviously, there are two options which are correct. So try this. Let me know which options do you think are correct. Okay. And I will show you a very, very interesting way of solving this. Something that you would usually not see. Okay. Okay, anybody? कोई कुछ कर भी रहा है कि नहीं? Let's see. Come on. अच्छा, ऑप्शंस में कुछ रिलेशन दिख रहा है? Let's see. Let's see if you guys can figure this out. Let us see if you can figure this out. This is a very, very interesting problem. Again, a wonderful problem for advance, I think. A wonderful, wonderful advanced problem. So typical concept, a slightly tough concept, advanced problem. Okay. And I'll show you a very interesting way of solving this. Very unique way of solving this. Okay. Again, there are traditional ways of solving this, but I like to solve this differently. So those of you who like, unique kind of solutions, different kinds of solutions, would appreciate this. Okay. So anybody, क्या हुआ भाई कोई ट्राई नहीं कर रहा है क्या पिछले सोल्यूशन के बाद सबने हार मान ली क्या ओके so why don't I do one thing let me tell you the unique way of solving this in any case so finally after everything let's imagine different values now let's imagine that this guy is moving with some velocity v1 this guy is moving with some velocity v and this guy is also rotating with some omega ओमेगा का डायरेक्शन क्या रखें ऐसा रख लिया मैंने अभी जानबूझ के interestingly this will be the direction of omega this will be the direction of omega okay so first I imagined everything so v1 I imagined is the final velocity of the plank v2 is the final velocity of the center of the cylinder and omega and that too I have given it an anti-clockwise omega okay which might seem absurd but turns out the omega would be anti-clockwise and why now what you want to do is draw the FBD of this cylinder है ना एक बार इस सिलेंडर को ध्यान से देखो एक बार इस सिलेंडर को ध्यान से देखते हैं so what are the forces that are acting on this cylinder G right of course right of course and friction will be in the forward direction right that is why it is gaining a forward velocity and that is why I said omega would be counterclockwise if you take the torques about the center the only torque external torque is due to friction that is counterclockwise that is why it will eventually gain an omega which will be counterclockwise okay so this is our FBD okay now comes the interesting part take a random point in the air take a random point in the air which is like this P. Now of all the forces acting on the cylinder what is the net torque that these three forces are producing about P now you realize N would be equal to mg at all times N is equal to mg at all times why because the motion of the cylinder is going to be in x direction only in the y direction the acceleration is 0 so can I say about point P there is no external torque on my system if there is no external torque on my system the angular momentum of the cylinder about point P cannot change so that is a very very interesting point so I can say okay I don't know how many of you will follow me on this so since there is no net external torque on the cylinder. Now P is a random point which lies on that line in the horizontal. On it may be a point on the ground, it may be a point on the in the air. Okay, on the cylinder, since there is no net external torque on the cylinder, about point P, the angular momentum of cylinder about P is conserved. Think about this and let me know if you follow. ये बात समझ में आ रही है क्या बोल गया मैं? हाय शिवम। हाय चलो शिवम से पूछते हैं ये बात समझ में आई क्या? So Shivam, here is a question. Yes you are. Yes you are. Here is a question. है ना, you've been told कि भाई एक 240 radius cylinder of mass 8 kg rests on a 3 kg carriage. है ना, ये सिलेंडर है, इसको ऐसे कैरेज पे रखा हुआ है and you've been told the system is at rest. Now a force P of magnitude 10 Newton is applied as shown for 1.2 seconds. Knowing that the cylinder rolls without sliding on the carriage, neglecting the mass of the wheels of the carriage, determine the resultant velocities of the carriage and the center of the cylinder. है ना, फाइनल वेलोसिटीज क्या होंगी इस मोशन के बाद, अगर ये फोर्स थोड़ी देर लगा के छोड़ दिया 1.2 सेकंड बाद, तो फाइनल वेलोसिटीज क्या होंगी कैरेज की और सिलेंडर के सेंटर की. ठीक है, ये पूछा है आपसे. This is what has been asked. Now, what I am proposing is, first I imagine that let the final velocities be like this. है ना, let's say carriage की final velocity v1 हो गई, cylinder के center की v2 हो गई, और cylinder has gotten omega in this direction, which is some omega. Now what I'm saying is that if I draw a horizontal line, which is passing through the base of this cylinder like this, tangential to the cylinder's bottommost point, and I pick a random point P on this. This is a point lying in the air, inertial point. So, is there any net external torque that is being applied on this cylinder about point P? अरे भैया ट्रांसलेटरी नहीं, इक्विलिब्रियम नहीं होगा. इक्विलिब्रियम कैसे आएगा? इक्विलिब्रियम नहीं आएगा, फोर्स तो लगेगा ना फ्रिक्शन का. इक्विलिब्रियम की कंडीशन क्या होती है? नेट फोर्स जीरो होना चाहिए. नेट फोर्स जीरो नहीं है, फ्रिक्शन का फोर्स लगेगा तभी तो वेलोसिटीज गेन करेगा वो. Why else would the cylinder gain a velocity? उसको वेलोसिटी दे कौन रहा है? बट जो भी हो, वो इनफैक्ट ओमेगा भी गेन करेगा. इफ यू टेक टॉर्क्स अबाउट द सेंटर पॉइंट, तो फ्रिक्शन एक टॉर्क भी दे रहा है. तो डू यू रियलाइज फ्रिक्शन कैन प्रोवाइड और विल प्रोवाइड एसीएम एंड अल्फा. तो इक्विलिब्रियम वाली तो बात ही नहीं है ना. हाँ, हाउएवर कुछ भी हो, पी के अबाउट कोई टॉर्क नहीं आ रहा, पी के अबाउट कोई नेट टॉर्क नहीं आ रहा. सो पी के अबाउट जो एंगुलर मोमेंटम है, दैट विल रिमेन कंजर्व्ड. दैट इज माय आर्गुमेंट. सो विदाउट हैविंग टू कैलकुलेट दीज वैल्यूज, I will quickly find a relation between V2 and omega, and I'll say initially angular momentum क्या था? Initial angular momentum of cylinder with respect to P वो तो zero था. Why? Cylinder was at rest. Final क्या होगा? Final देख लेते हैं. So due to this translation, it would have had a negative angular momentum minus mvr, and due to this rotation, it would have had a positive one. It would have been ICM times omega. समझ गए? और ये आना चाहिए zero. So therefore, what I'll say is mvr would be equal to e by 2 1 by 2 mr square omega. Agreed. तो यहां से क्या आ गया? यहां से आ गया आपका omega r equals 2v. Omega r is 2v. Now, how about the velocity of the bottommost point? Let's focus on the bottommost point now. ना इसकी क्या वेलोसिटी है? ये किस स्पीड से भाग रहा है? इसकी जो वेलोसिटी होगी वो होगी v2 प्लस ओमेगा r. ये बात समझ में आ रही है? Because the CM is going forward with V2, and with respect to the CM, this is going forward with omega r, so the ground frame velocity would be this. So, and since omega r is equal to 2v2, since omega r equals 2v2, so can I say that the velocity of the bottommost point, which we are calling O, velocity of O would be equal to 3v2, which is v1. Because there is no slipping. So आपका plank भी उसी speed से चल रहा होगा. Agreed. So I found a relation between v1 and v2. I found a relation between v1 and v2. Now, interestingly, all I need to do is add page first. Now I say that v1 I figured, so v1 equals 3v2. So the total momentum कितना हुआ? Therefore, total momentum of the system that will be mass of cylinder into v2 plus mass of carriage to v1, and this should be equal to the total impulse momentum theorem. Right. Okay, Shivam says, sir, I'm not getting mark by doing so much hard work. अरे नहीं भाई, ऐसा कुछ नहीं है, ऐसा कुछ नहीं है, ऐसा कुछ नहीं है. थोड़ा सा और ऑर्गेनाइज करो, थोड़ा सा और प्रैक्टिस करो, थोड़ा सा कॉन्फिडेंस आएगा. कहाँ मार्क्स नहीं आ रहे? कहाँ मार्क्स नहीं आ रहे? ऐसा कुछ नहीं है. इफ यू आर वर्किंग हार्ड और ध्यान दे रहे हो तो आएगा. ऐसा कोई रीजन नहीं है नहीं आएगा यार. कैसी बातें कर रहे हो? अच्छा, इसका मास 8 kg सिलेंडर का and 3 kg for the carriage. I can say 8 to V2 plus 3 equals force was 10 Newton. It was applied for 1.2 seconds. What I'm getting is 17 V2 equals 12, or V2 would be 12 over 17, and V1 obviously would be 3 times this, so 36 over 17. तो ठीक है, लेट्स सी कहाँ गलतियां कर रहे हो, कौन टेस्ट में क्या गलतियां की, उन पे फोकस करो. नेगेटिव मत हो. आइडेंटिफाई योर मिस्टेक्स एंड वर्क ऑन देम. अगर आप हार्डवर्क कर रहे हो तो कहीं तो कुछ तो कहीं दिक्कत हो रही है, कुछ तो कहीं गैप छोड़ रहे हो ना. सो लेट्स ट्राई एंड आइडेंटिफाई दैट गैप and don't worry about it. So this will be roughly 2.1, and this will be roughly 1/3 of that, so 0.7. So 2.1 and 0.7 are my answers. टेंशन मत लो. एक काम करते हैं शिवम, मंडे को मेरी क्लास है फ्लूइड और ग्रेविटेशन की प्लस पे, राइट? मंडे आई हैव अ प्लस क्लास. So why don't you come to that and bring details of this test where you did not perform well. Let's see what was asked and where you went wrong. It's okay if you are putting in hard work, कहीं कुछ मिस हो रहा है छोटा मोटा, and we need to just identify that and address that issue. ठीक है? Don't worry about it. उसको जरा आइडेंटिफाई करते हैं कि कहाँ गैप आ रहा है आपके समझने और डिलीवर करने में. Yeah, and we will identify that and we will address that issue. Don't worry about it. We'll be fine. You have a lot of time. होता है. किसी ने नहीं कहा आसान होगा यार. हर्डल्स तो आएंगे. ऐसा नहीं है पहले हर्डल पे आप हार मान के बैठ जाओगे ना. हाँ यार, ऐसे नहीं होता. डोंट वरी यार, सबको प्रॉब्लम्स आती हैं. एवरीबडी एनकाउंटर्स प्रॉब्लम्स. हाँ, ये सबके साथ होता है. ऐसा नहीं है कि डिमोरलाइज हो जाओगे कि नहीं नहीं क्या मेरे साथ ही कुछ गलत है. नहीं भाई, ऐसे नहीं होता. जो प्रॉब्लम है, परेशान होने की जगह लेट्स आइडेंटिफाई द प्रॉब्लम एंड लेट्स टैकल इट हेड ऑन. ठीक है? On Monday in the plus class, we will have a discussion, you and me. We will try to identify where the problem is happening, okay, and we will try to find a solution. And don't worry about it. सब सही हो जाएगा, परेशान मत हो. ठीक है? Okay, so this is how you would have done it. Again, this is a non-traditional way of solving. You have a lot of traditional ways also towards solving this. You realize I did not even need the इसकी भी जरूरत नहीं पड़ी मुझे रेडियस की, है ना, इस सोल्यूशन में. Okay, so again, this is a non-traditional way of solving, but this is one method that I really love of solving this problem. It requires only very few equations, a lot of common sense, and that's about it. So you do need to think a little, in this problem. But if you can think a little, then you realize the kind of equations that you're forming are so simple, and the mathematics of solving is very, very simple. You realize this was such an easy solution. Now, okay. Now that is it. One last problem, but this I would like you guys to try for homework. This is a very, very interesting problem. It says a uniform plate of mass m is suspended in each of the ways shown. For each case, determine immediately after the connection B has been released the angular acceleration of the plate and the angular acceleration of this and the acceleration of its center of mass. Okay. Let's see. So you have been shown three situations. In three situations, identical rectangular plates have been hung. In the first case, it is hanging by two pins. It is hinged at both the ends. In the second case, it is hanging with the help of wires. In the third case, the plate is hanging with the help of springs. Okay, so initially, all three are in equilibrium. All three are identical plates. Now what you do is you immediately lose the connection at B. You remove the connection at B. You remove the connection at B. So just after that, what would be the ACM and the alpha of the plate? That is the question. Okay. So this is something that I would like you to think about. Give it a lot of thought. Try to solve this and leave your answers in the comment section if possible. So try and leave answers in the comment section. Okay. Again, this is a very simple looking problem. Very simple looking problem. But again, when you solve this, you will gain a lot of concept clarity. So these kind of problems are very, very important for getting concept clarity. Okay, trust me, it appears simple, but when you solve it, you will be confused. I can promise you that. Okay. So try this. This is a very good example of a problem that can easily be asked in advance. Okay, so this is where I would like to wrap it up for today. That is all the problems of rotation that I wanted to discuss with you guys. So yes, if you solve these many problems, if you have understood these many concepts, then trust me, you have nothing to worry about rotation. Okay, so if you're following this, if you've thought of everything, if you are building that thought process, then rotation would be sorted for you. With that, let me just tell you one last time that if you haven't gotten your Plus subscriptions, you should be getting them, and this is how you do it. Go to the Plus section of your app, select your goal as IIT JEE, and click on that Get Subscription button. All right. Now, when redirected to the payment page, do not forget to use this code RD Live in the box which says, "Do you have a code?" Okay. Now you can choose from two kinds of subscriptions, Plus and Iconic. So choose a subscription that suits you better, and click on Proceed to Pay and choose a payment plan that suits you better. Okay. Now, the Iconic subscription is a new kind of choice that Unacademy gives you. You can go for this subscription. This will take your IIT preparation to the next level. How? By assigning personal coaches and by giving you these extra benefits. Okay. Next, you can compete and test your knowledge and understanding in the next Unacademy Combat, which is going to happen live on the 3rd of January. And you can enroll now for that using the code RD Live. And if you do well in that, you can win a lot of cool rewards and prizes, including year-long subscriptions of Unacademy Plus. Now, if you like today's video, don't forget to hit the like button and share it with as many people as you can. Okay, share this quality free content which is being given so that more and more students can benefit. So it's your responsibility to keep sharing this kind of content so that more and more students can benefit out of this. Okay, now if you're new to the channel, don't forget to subscribe and don't forget to press the bell icon. Okay, so that's it. If you are following us on the JEE English channel of YouTube, you can also connect with us on the Telegram app using this link so that you are constantly receiving all the notifications of all the amazing sessions and lectures happening here on this channel. All right, so that is it. That is where we will end today's session. Okay, and please remember, this is my code RD Live. So next time you're planning to get your Unacademy subscription, you can use this code and get a wonderful, wonderful 10% off. All right. With that, I will take your leave. You guys keep practicing, keep studying hard. Try that problem, the last problem that I have given you as homework, and try to leave your answers in the comment. All right. So with that, take care and bye bye.